Okay, thank you, everybody. So we're going to shift to still infrastructure, but we're going to be, how about now? Okay, so we're going to shift to on-prem topics within infrastructure stream. So for this discussion, we have Steve Bristow and Miguel. And there's some nice pictures. Steve is online on the Zoom. And so we want to extend the discussion about infrastructure as code. And for those that were here or were present for the last convening, I made a presentation regarding extending the IAC code base to make it cloud agnostic. And I also had a portion of the effort dedicated to making that on-premise capable, right? So the code has been refactored to support multiple cloud vendors as well as on-prem. And with that in mind, what we wanted to do, because there are quite a few interested parties in running on-prem, we wanted to discuss what are some of the topics related to running Mojaloop on-prem. And some of that obviously comes down to just running Kubernetes on-prem, but there are some specifics related to Mojaloop. So, of course, we're saying on the left side, up until now, the Mojaloop deployments that we've been dealing with have been cloud-based. And these have the obvious cloud benefits associated with them. But on the right side, there's customers that are going to favor an on-premise deployment for various reasons. And we don't have to go into them in detail. And a lot of us know what they are, but they come down to compliance issues most of the time. But with that in mind, we want to make sure that Mojaloop is available to everybody. Am I kicking something here? Oh. Okay, so we want to make sure that Mojaloop is available to everybody, including those that need to run it on-prem. So that's the reason why we want to take the IAC, which allows you to have repeatable deployments of a Mojaloop switch on cloud, and we want to extend that to on-prem so that everybody who is deploying on-prem can get the benefits of the work that we've done in the cloud-based IAC. So, and I think it's worth mentioning the second bullet point here, that it's on-prem deployments is not going to be a turnkey process. So we want to talk about why is it not a turnkey process? What are some of the things that you have to keep in mind when you're doing an on-prem deployment? And for that, I'm going to hand it over to Steve.
Hi, you might have to bear with me a moment because I can't see the outgoing slides, I'm afraid. So this might be a little bit ad hoc. So David, can you just tell me which slide you currently have on the screen?
We're on the on-prem challenge, the spaghetti table.
Fine. Okay. So yeah, as I guess you're all probably aware here, data centers aren't easy things to own and manage, and putting something as complex and possibly demanding as Mojaloop in there isn't without its challenges too. So finding an appropriate data center for your availability model that has adequate cooling, adequate cabling and power. I mean, you can see from the examples in the photos, the sort of the two extremes of cabling. It's got the correct levels of physical security, all the usual things around being internet adjacent, diverse routing so that your links going down can't impact you, that they're nice short low latency links. It's got all the right availability technologies in there, as well as you understanding what the maintenance windows are for those data centers, how many sites you're going to use, how you manage unplanned outages, all of those problems. But now you're throwing on top this massively scalable switch that's potentially going to have huge workloads. So now support contracts come into the question. Do they scale with your workload? Can you get hardware? Can you purchase that hardware with the funds available to you? The quantities of hardware, are they available in the channel with manufacturers? Shipping costs, shipping times, lead times, bill of materials. all of it comes down to predicting the growth, having an adequately planned business case that delivers return on investment in a timely way for you to make your next investment with the switch. Essentially, the 5-year forklift cycle just doesn't really scale or work with Mojaloop. So if we go to the next slide, please. So the key driver to this, we can go to the next slide, is availability. Nobody likes outages, but let's just put some language around those. So a 1-minute outage is probably going to be absorbed by DFSPs. It's going to go unnoticed by the public. It's going to go unnoticed by regulators. 5 minutes, things start to get a bit more interesting. You're going to get the DFSPs timing out. You're going to get transactions aborted or customers retrying, just one retry. Again, probably not going to be of any concern. At 10 minutes, things start to get really interesting though. Customers retry and retry. The system is now perceived as having a problem by the majority of people who are using it. At this point, there's probably going to be a phone call from somebody senior saying, hey, what happened yesterday? At 20 minutes, repeated retries fail. Now you're looking at reputational damage. Now there's going to be somebody asking for a report on what happened in that outage yesterday. Over an hour's worth of outage, customer outrage begins. You've got severe reputational damage now that you need to recover from. Expect somebody to demand an audit. So high availability is expensive, but it's not something you buy on its own. It needs to be viewed in the context of the risk appetite. So you decide how much risk appetite you have, how you're going to mitigate it, you document that risk appetite and agree it with all the vested parties, company, regulators, whoever, and communicate that out, and you set it before you go live. And then you make a solution design that meets that agreed level of risk appetite and outage and so on and so forth. So that's just a sort of level set on context. So if we go to the next slide. There's a few different ways of solving availability problems, which I'll go through these very quickly because they are quite boring. The classic is the active-passive model. Everybody connects to one data center, everything replicates in real time to another data center. In the event of a problem, you have failover detection or your traffic moves over to the other data center. However, this has got its own problems in that your secondary data center is synchronously replicated, which means your primary data center has to wait for it to write its records. Otherwise, in a failover, you lose records. So you can only go as fast as your slowest data center in this scenario. And the other problem with this scenario is that if you take down your secondary data center, your passive data center, which is 50% of your infrastructure sitting there doing nothing all the time, just logging transactions. If you take that one down for maintenance, then you have to disconnect it from the primary and then it has to play catch up later. So it's not without its own risk. It's not as passive as you think. So we'll go to the next slide, please. This is not a recommended approach, but it's one I've seen implemented, which is active data centers with no third node. You run the risk of split brain all the time with this. There's no simple way around this. You have two deployments in two separate data centers. The replication network becomes partitioned, or any other form of comms partition occurs, and you suddenly have two data centers that both believe they're the leader. And at which point you've now got two records of completely separate transactions. And at some point, somebody's got to take the whole thing offline and replay that into a coherent chronological sequence in one of those data centers. I've never seen this not result in days worth of outages. Very much not a recommended scenario. So if we go to the next slide. How do you mitigate against this? You need a third wheel. So you have an active data center, and then you have a third location, whether that's a small site that's going to run a witness server, or whether you say, actually, my witness server still needs to be as highly available as the rest of my infrastructure. So if I'm going to have a third data center and all the costs that entails, I might as well deploy a third stack. The 3 model is very, very strong in terms of you can lose an entire data center without impacting your transactional flows. You only really need to reserve 30% of each of your infrastructure stacks, rather than having masses of it sitting unused. You've only got 30% unused in each data center. And if you're then doing maintenance, you can take one of these out of the loop and just leave a witness running in the other data center. Again, no outage, much less risk. And because you're distributed across 3 locations, you ameliorate a lot of throughput issues. So the preferred model generally for something at the scale is probably the 3 data center model, as long as you've got good internet adjacency. Okay, so let's go to the next slide. Scaling. So scaling is the other kind of the other side of the fork, I suppose. With this, there are challenges. Your switch is going to have different traffic patterns to everyone else's, and the only way through this is to try before you buy. Scaling up across a nation is utterly unpredictable. I don't think anyone really knows what's going to happen, so the platform's got to scale quickly and easily. And then buying hardware up front is a huge investment if you're going to just fill up a data center full of equipment. So what you want is a solution that's scalable and can scale with your needs. Unfortunately, there's minimal publicized data about the real world performance of Mojaloop in the various different markets and deployments out there. So actually forming a baseline is tricky. Can we go to the next slide, please? So to address the first part of this, the scalable solution, we propose something called Mojastack. This is an HCI solution based on multiple nodes in a stack. It could be in a rack, it could be across several racks connected by 100 gig switches. What this means is there's no separate storage array. There's no separate backup array, for example. There's not different boxes doing different things. You end up with a relatively homogeneous stack of HCI resources where storage is replicated between them. It means that it's commodity hardware. So you're not forced into a single vendor's high availability solution. You can buy any badge you want to, and you can mix and match if needs be, which means that you're not restricted by shipping times and pipelines. If your needs change rapidly, you can go out and source any box of similar spec and then add that to the pile, and you've got a faster switch. 100 gig networking, whilst it sounds expensive, is becoming progressively cheaper and cheaper. So again, is a great way of unlocking this hyper-converged infrastructure. The software on this, the availability is software centric. So these are cattle, these aren't pets. A server fails, the cluster reacts appropriately. Again, no expensive support contracts, no difficult vendor engagement. So if we go to the next slide and give an example of this, open source software doing this for us. So Kubernetes is highly fault tolerant and has relevant monitoring and availability components within it, as does storage systems like Ceph. So in the event of a node failure, in the event of a component failure within the node, then the node will announce it's degraded. Storage will be remastered onto other nodes. It's already replicated, so it's simply moving from one node to another one in terms of where it connects to across the network. And then the workloads will be rehosted adjacent to that storage as and when there's an appropriate timing. In the event of a node failure, a node will completely disappear. Any active workloads and active transactions running on that node, they're gone. So the customer's going to get a retry message, or the DFSP is. But storage, again, will be remastered onto other nodes, and workloads are going to be, again, rehosted to get adjacent to that storage. So if we go to the next slide again, please. The other part of this problem is the scale. Understanding when, how, and so on and so forth. So what we propose is firstly to validate a set of baseline workload assumptions. So deploy a cloud bare metal instance of Mojaloop and tweak that hardware, run with different patterns, build out an identified standardized workload that we can drive that against. We can seek out that optimal price performance configuration. Again, availability is not an issue for this one. The intention is to actually get to a platform that can be scaled and has an understand how the hardware influences the workload. Could we pop to the next slide? Thank you. So how do we arrive at this hardware agnostic solution? MicroK8 SHA, as discussed here, it's a Kubernetes distribution that supports easy adding and removal of nodes. It's easy to configure, it's great. Metal LB is a load balancer implementation designed for bare metal deployment on Kubernetes. Again, widely used now, very fast, very flexible. Core DNS removes a lot of the dependency on cloud DNS services and brings them down into the Kubernetes cluster. Ceph storage, super fast, super resilient, very configurable, and can offer block, file, or object storage depending on which component needs to run it. And one of the key parts to integrating Ceph with Kubernetes is Rook. which orchestrates the Ceph storage via the operator model. And next slide, please. So this next step in this process is to define a pattern of transactions that constitutes a typical workload. So transaction traffic would be based on busy periods. So we can model paydays, national holidays, etc. And then generation of the workload would typically be outside of the cluster that's under test, ensuring that there's no leakage of other workloads into the platform. Any limitations that are identified in specific hardware or software components can then be accommodated for by scaling the software out horizontally, or indeed, as we found in step 1, adjusting the hardware platform. Next slide, please.
Thanks, Steve. So I'll just add on to this basically. As Steve mentioned, there hasn't been a lot of like published characterizations of a Mojaloop switch in the wild. And I have spent quite a bit of time characterizing the Mojaloop switch in the past, as well as also participating in the VNext POCs that were also widely characterized as well. But one of the things that we basically learn is we need to identify the limits of the underlying systems themselves. And over here, you can see basically 3 pillars that we want to concentrate on when we do the characterization, when we understand the limits of the actual system itself. We have the infrastructure itself, we have the persistence, which is the storage, etc., the databases, MySQL, and we have the application itself. So you can think of this almost like a layered approach, where we would first do the underlying layers first. For example, the infrastructure, we would understand the input outputs of that infrastructure, the networking, the ingresses, egresses of that, the proxies, the gateways, as well as the actual raw storage of that from a logging, auditing perspective, etc. And as well as the scalability of that. So as we scale that infrastructure, what are the impacts to the latencies from a network perspective, from a replication perspective, etc. And something else I want to also ensure that we don't forget is about the security aspects. Often very much people forget about the security. We need to make sure that's also included, and we need to understand what is the impact of that security, what is the overhead of it. And then on top of that, we would move to the persistence layers. And this is, once again, is Kafka, MySQL. And we would very much do a similar exercise where in somewhat isolation, we would understand the limits of what can Kafka do on this hardware, what can Redis do on this hardware, etc. And that's very important, because when we get to the application layer, we need to understand when we hit the limit of the underlying persistent stores and the underlying infrastructure stores, etc. So that's a very important aspect, is also making sure that we test these in isolation with that as a result of that. And when we talk about application, we're not just talking about Mojaloop specifically, we're also talking about any other component that is running within the Mojaloop stack as well, right? So any of the monitoring infrastructure, etc., that may impact to the actual execution environment itself. And on the bottom left and the right, we also have simulators. We need to make sure we have simulators that be able to sustain and be able to handle the particular workloads that we want to push through the system. And we also have tooling itself, which is about how we generate that load, and as well as monitoring the actual throughput through the system, etc., and the resources. Steve?
Thank you. Okay, which takes us to step 3 of the process. It's defining a standard hardware pattern for on-premises deployment, not in a production way, but in terms of taking the baseline data that comes from testing and then allowing a Mojaloop deployment to implement that in a lab environment on premises in their own network, and then run friendly user testing or a scalable POC on that. So the target for this platform would be moderate specification. This has got to be something that's achievable without kitting out a data center for a low availability, easily attained baseline POC, for example. It needs to be customer centric, right? This is for anyone to go out and buy. This needs to be the commodity hardware that ideally you can buy in a shop rather than having to order. It needs to be vendor agnostic. Again, we don't want to be wedded to badges. We want the commodity hardware that you can just get anywhere. And then the failure protection for this is in software. There is no hardware failure protection. There is no redundancy in anywhere. This is just about proving a workload. So if we go to the next slide. This is a typical example of something that would scale out to very large numbers of users and support a lot of parallel, quite a lot of parallel testing on it. these are high-end workstations. So you know, there's a point between this exemplar spec and what you're trying to achieve with it. But this is a good example of what can be done. The unit cost for these is $3,500 to $4,000 per machine. You're going to need 3 of them, but it includes optionally 25 gig network, minimum 10 gig network. You've got 1 terabyte NVMe SSDs in there, which again can be configured to run in RAID 0 for massive levels of throughput. Or you know, you can have separate disks if you start identifying that there are pipelining issues with the workload. And we've opted for Ryzen CPUs, higher clock speed, better throughput than Intel. Whilst being vendor agnostic, this is the cheapest way that you can get to 24 or 64 or however many cores. The 24 core option shown is a great sweet spot for testing with, you know, hundreds of users in parallel. And again, the number of cores is critical because in an HCI environment, your storage, your containers, your databases, all these things are running in parallel in a single box. So that the more parallelism you've got is more important than just going flat out fast. Although some might argue that 4.5 gigahertz is pretty quick. I think it's a general indicator of just how powerful these boxes are, that they've got 1,000-watt power supplies in them, and these don't have GPUs in. So if we move to the next slide, this is just a typical example of how this could be deployed. A cheap 10 gig switch. Bear in mind, 10 gig networking is now available for hundreds of dollars, not thousands. So again, this can be a commodity switch from your, you know, your local reseller store, whatever. This lab can be used to allow you to model customer workloads on-prem at scale. These nodes can be used to test each other. You've got the 25 gig option, so you can actually do storage replication across all 3 by just putting it in a separate VLAN on that 10 gig switch. It's just a highly performant scale-out model for a Mojaloop deployment. In the example given, node 3 can be configured to actually test a 2-node cluster, or you can open this up to multiple machines on the network and have developers test against it. Or indeed, if you know, as long as your availability isn't a concern, this can actually be used to do a basics deployment and see what your user traffic looks like coming in from the internet. But again, this is not a production-ready architecture. Could we go to the next slide again, please? So how do you get to production ready? So I think Mr. Fry was going to talk through this one.
Thanks, Steve. So this is kind of the summary conclusion slide. So if we look at all the slides up until now, there's a lot of talk about scaling. There's a lot of talk about the characterization of the platform. What we want to do is say, from a process perspective, what we need to do is, from an IAC development perspective, we want to continue the refactoring of the IAC to support the on-prem. And there was components showed by Steve earlier that we're suggesting would be the preferred components for an on-prem deployment. So part of the refactoring of the IAC would be to bring in those components, and that's Metal LB and Core DNS, and using, instead of what we use now, CubeSpray, you know, we'd be using micro K8s. So there would be changes that would need to be tested. Those would be tested on AWS so that we don't have any procurement costs that we would have to bear in order to test the solution out. And then later, after we've tested out the IAC and it is a repeatable process that can be tested on AWS, then the next step we would be looking at testing out on some commodity hardware. That was an example was given by Steve there. And then what we would have at the end of that would be a testable code base for running on-prem using commodity hardware that could be used as a lab or a testing environment for somebody on-prem. Then the next stage would be to actually test that out, see what your actual characterize your load, and then iterate off of that, make changes, and then that would be the basis for your production deployment. So don't know where my slide went, but that is in a nutshell what we're suggesting as the path forward. Yeah. So standardize, get the data set for the testing. So that's the characterization. Refactor the IAC to support on-prem. Oh, thank you. And then, oh, okay. Well, I'm just going to finish it up there.
See, availability has long-reaching impacts. Look.
Yeah, exactly. Well, sorry about the AV issues. Steve, is there any final words that you had? Because
no, I think it's really exciting to be talking about developing the IAC to be on-prem and giving that back out to the community with ideally some template designs, just so that this can really start to grow for people who are constrained by governance and by compliance requirements. So this seems to me to be huge, and building something that can scale with your business. As money moves, then transaction levels grow up. And to build that stack out, I'm really excited about using HCI as a model for delivering this without having to, forklift kit into a data center from day one.
Yep. So I think that touches on two of the pillars that have been brought up, and one is to encourage adoption by the on-prem community, and the second is scaling, because coming up with this model allows us to scale in a much easier and low cost fashion. So I think we wanted to make sure that we bring it back home to the pillars. So, yes.
So we had a challenge when we went through characterization a few years ago with using AWS, which was it was not possible to stand clear of IO throttling and other resource throttling. How are you going to do that here? Or is it that you're only going to run until they throttle you and then you stop and restart? And I mean, how do you actually get to where you're really modeling bare metal box? Because what they call bare metal isn't really bare metal. It's close, but it isn't quite.
Steve, did you also hear that question?
I did.
So
go on.
Yeah, so from my perspective is, yes, the bare metal will never be exactly like on-prem, but I think the important thing is it gives you a good indication of what you would see on-prem, and you would expect on-prem obviously to do better. But at the end of the day, you don't want to go and shell out a ton of cash on hardware and you don't even know how it's going to actually perform, right? So
I have no issue with the approach.
Yeah.
What I'm saying is the approach actually practical, and will you get what you think you get? Because RIO throttling that they were doing during our cycle was enough to basically crash the results. They were useless.
It was always a problem, right?
Yeah.
And one of the issues we had was because we didn't use bare metal, right? We used shared infrastructure within the cloud. So using dedicated bare metal hardware hosted in the cloud gives us some guarantees that we never got before, right? So previously on the shared hardware that we had, there was always a up to 10 gigabits of whatever storage or speed or whatever. And in this case, when you get bare metal, you get 10 gigs of speed or storage, right?
Yeah,
so
up to includes 0.
Exactly, includes 0. And it depends on what's being used and you don't know. And a lot of the time, those, one of the issues we had with, in fact, AWS was that some of those indicators that were being throttled were not visible to us. And we were not able to even see those things. So by ensuring that we have bare metal, we have a 100% clear indication of where we are being throttled with regard to those guarantees, right, that are offered by the bare metal provider.
And that's where I was going, was that some of those things were buried so far that we spent, I don't know, weeks blaming the database. It wasn't the database that was the problem. So
100%.
Yeah. Okay, fair enough. So you're actually, this approach isn't really the same we had before. This is actually attempting to run real hosted
100%.
boxes. It would be like going to Rackspace and saying, I'd like X boxes.
Exactly. It doesn't have to be a cloud provider. It can be anyone who can offer bare metal infrastructure to be able to test this. And I think the important thing also is to potentially, or the opportunity here is before you even go and buy hardware, is to be able to test maybe certain, let's say, configurations and see maybe where the sweet spot is from a cost versus performance perspective, right? And in terms of understanding how does that scale,
Yep.
So maybe we can save a bit of money now, but if we do save that money and we add more hardware, what is the impact of that, and how does
Yeah.
it scale? Does it make sense? Is
Well,
it
there's two things you
feasible?
want to learn from it. So one is I can characterize the unit load, and I understand how many boxes I need to run that unit load and how I configure them. I very much like the cattle, not pets analogy. I love that. We used to talk about it as the difference between Bentley servers and Volkswagen servers. The Bentley server, you just hope to God it doesn't fail. And with a Volkswagen server, you assume it's going to fail, but you have a suite of them and you can allow them to be switched out. So we're designing for that pattern. But then the second part on that scale axis is, can I scale at sublinear cost? That is, my baseline is 4K per server and I need 10 servers. I don't know what the number is. But then to get to the next doubling of that volume, it's not an extra 10 servers. It's an extra 2 servers or something like that. We need to know what's the curve look like for that.
100%.
So that's on that axis. On the other axis, are we going to, are we confident that we'll have something that we can go to market and purchase? That is, we're using bare metal in the cloud. Can we buy that?
We have to make sure that when we choose the bare metal, it needs to be something that is accessible, right?
Yeah,
It has to
acquirable.
be. Yeah, we can't just go and choose any bare metal and it's not, it has to be available to people and an option for people to be able to do that.
Brilliant.
So that's definitely a consideration. And then something else that's also worth mentioning is by using on the bare metal options, it means that basically the AIC team, so David, et cetera, can build that on-prem configuration or those changes to the actual AIC to be able to support the actual deployment going forward. So we don't have that necessary upfront cost of having to buy hardware, so we can actually even develop that stuff.
There we go. Another question for you guys. Building on the work that we did for the performance POC, where we concluded that it was not necessarily the hardware that was the limit, but the design that intensively uses the SQL database. So it's not exactly the database is not the problem. It's the way that we depend too much on a single database that is a problem. So starting with that acknowledgement, which was the result of a long period of testing and a lot of hard work, how do you see this hardware making a difference? Because picking up on that report that we wrote, that's not supposed to happen, because more hardware is not going to fix the problem after a certain limit. You're always...
No. Yeah, it's exactly. And it's about determining, I need to get this many transactions per second. What is the IO that I need to support that, right? What is the database that I need to be able to support that potential, let's say that constraint or whatever, right?
But going back to the scalability point that you raised, Miller, which is the unit of scale. And that was one of the most important aspects of the performance POC, which is, if I have one more server, do I get twice the performance, which is the typical linear scalability, or almost, we'll never get it. And what we concluded was it requires a slight change in the way that we're splitting things. And this is what
I know. We want to start first with, how does it run? We're not saying you must run at X TPS and all that. No. Set it up and run it. How many TPS can you process? Okay, that's the baseline. Now we've characterized it. Then we can go back and say, I want to run twice whatever it was that I characterized it running. How much hardware do I need? Now I've characterized the scale. We're not going to be happy with either of those. We know that.
we did this.
But
No,
to do with this
no.
software.
We did a subset of it.
Yeah.
We did only transfers. This is everything. This is the entire Mojaloop stack, right? So it's different. This is the complete shebang, as it was. I think we're out of time, guys. Thank you so much. Thank you, Steve.
Thanks,
It
everyone.
was great to hear you. Great to hear you, Steve, and see you as well. Thank
Good
you.
to see you all too. Thank you.